Okay, we're going to learn some tricks to being able to factor some things a little quicker than we normally do. So if you remember back to how we would factor this normally, we would do what multiplies to be a times c and adds up to be b, which would be 4 times negative 4. And then we would quick factor this, so this would factor to be x plus 4, x minus 4. What I want to point out here is we have conjugates. Conjugates means change of sign in between the terms. And if we have conjugate factors, the middle term will always cancel out. So if we have no middle term, that means it will always factor to be conjugate pairs. So we're going to use that trick from here on out if we have two perfect squares, that is. So if I take the square root of x squared and the square root of 16, I get x and 4, making those perfect squares because they came out perfectly. Then we have no middle term, and so it factors to be x plus 4 and x minus 4, conjugate terms. Now here's one thing to note. It does need to be subtraction because addition will not work. So let's check out why that is. Well, multiplies to be a times c and adds up to be b, 4 times negative 4, which would not be negative 16. There are no factors that would multiply to be positive 16 that could add up to be 0. So this one does not factor. So this rule, I gave you this trick, only works if it's subtraction, if it's the difference of two perfect squares. So we have two perfect squares. It's the difference, so this we can use our trick, x minus 2, x plus 2. They'd be conjugate factors. This one would be the difference of two perfect squares. So this would factor to be x plus 7, x minus 7. Alright, and then with addition, once again, if we have two perfect squares with addition, it will not factor. And then, so this won't factor either. Alright, so right here, if we have no middle term, and it's two perfect squares, it'll factor to be conjugate pairs. Once again, we can't factor it if it has a plus sign. Now, there is another thing that happens that we can use as a trick. If we go back and do this the good old-fashioned way, what multiplies to be a times c, what multiplies to be 81, and adds up to be negative 18, that would be 9 times 9, and they'd both be negative. We can quick factor, so this will factor to be x minus 9 times x minus 9. Or we can write it as x minus 9 squared. Now, we can actually use the same type of trick. So this will kind of have a trick as well. Not the same type of trick, so we know if the middle term cancels out, there'll be conjugate signs. Well, if the middle term does not cancel out, then we can actually see if a trick will work for this as well. So look, we have a perfect square and a perfect square. So if you square root this, you get x. If you square root this, you get a 9. Now you do need to check, because we know we're going to end up having two of those. You do need to check, when you multiply it out, you'll have one 9x and another 9x. Does it add up to be 18? Because I could have a different polynomial, x squared, I could put in plus a 2x plus 81, and those are still perfect squares, but the middle term is not something that if you were multiplying it out would add up to be the correct thing in the middle. So we do need to check. We have an x and a 9, so that's 9x, and there'll be two of them. 9x and 9x is 18x, so it does have a trick. Now it needs to be a minus sign, so minus, minus. So it's kind of a trick we can use here. So if we were to apply that trick down here, we'd say we have two perfect squares. So if we square root this, we get x, square root 81, we get 9. Now we know we're going to have two of them. So if we have x and 9, that would be, x and 9 would be 9x, 9x and 9x would be 18x, so we're good, we can use this trick. So then because it's a plus sign, it will be plus, so it'll be two pluses. Now think about why this works. X squared plus 9x plus 9x, there's our 18x, and then plus 81. Alright, let's see if we can use that trick some more here. We have two perfect squares on the ends. We have a middle term. So we square root this, we get 2x. We square root 25, we get 5. Now 2x and 5, 2x times 5 is 10x. And we're going to have two 10x's, which would add up to be 20x. So we can use our trick. So we have a 2x and a 5. And then because of the plus sign right here, it needs to add to be positive 20x, so we put plus signs in, which could also be written as 2x plus 5 squared. Okay, let's do this one. Two perfect squares. So we have a 2x, we have a 5y. If we were to multiply those together, we would get 10xy's. We're going to have 2 of them, which does add up to be 20xy, so we can use this trick. And then we put in 2x and 5y, and then because they're both positive, it needs to add up to be positive, we will have plus signs. So once again, guys, I'm just restating why we have to check to see if the middle term is correct, because I could have had this, 4x squared plus 22xy plus 25y squared, and then this trick would not work, because the middle term would not add up correctly. Okay, so we have 2 perfect squares, 3x and 4, and then the conjugate will be our answer because our middle term cancels out and it's subtraction. So we have 2 perfect squares again, and then there's no middle term and it's subtraction, so we're going to have conjugates since the middle term needs to cancel out. Alright, so looking at these are all the different types, but the same look to them, all perfect squares, but with different ideas. So we square root this front thing, we get 3x, square root the back thing, we get 8y. Now we need to check. 3x times 8y is 24xy. We're going to have 2 of those, which is 48xy, so we can use our trick of perfect squares. So we have a 3x, we have an 8y. Our middle term did not cancel out, it's positive, so these are going to be plus signs. Alright, so same thing here, we have a 3x, we have an 8y. 3x and 8y is 24xy's. We're going to have 2 of those, which is 48, so we are good to use our trick, and it's subtraction, so they're both going to be subtraction. We have 2 perfect squares. Our middle term cancels out, that means I need conjugates. Right here we have 2 perfect squares, but our middle term cancels out and it has addition, so we can't factor that. Alright, so factoring this one, the square root of that, the square root of that. So this would be 16n, and it looks like 9n, conjugate pairs, since our middle term needs to cancel out. And we're done. Okay, 2 perfect squares. Middle term canceling out. 2a, 3b squared, and they need to be conjugate pairs since our middle term's canceling out. Alright, looking at this, make sure you don't forget that really before we start any form of factoring, we have to factor out a greatest common factor. We just absolutely cannot forget that that's our first step. So I pull out a 2, so then let this 16x to the 4th minus 1, then I have to check, do we have what type of factoring going on? 2 perfect squares. Square root, so we would get 4x squared and a 1. And middle term canceled out on this one, so we have conjugate pairs, plus and minus. Then you'd have to check. So we look at our final answers always and say, okay, could it factor more? Are any of those able to be factored more? 2 is good, but this is another 2 perfect squares problem. Square root that, we get 2x, square root that, we get 1. So this piece has no middle term, and it's conjugates because of the fact that I have no middle term. So that piece just factored to be that. We still have a 2, and then remember this won't factor because we have 2 perfect squares, but it has addition. So then we would have 4x squared plus 1. We have to make sure we factor everything completely. Alright, let's factor these. This is factor. So remember, if we have 4 terms, we factor by grouping. So I pull out the greatest common factor, which is x squared, giving me x plus 1. Pull out a positive 4. Left is x plus 1. It did factor by grouping since my safe haven is the same, or if what's inside parentheses is the same. So I pull out x plus 1, so it divides out, leaving me with x squared plus 4. I better check, will that factor more? It is 2 perfect squares, but it's addition, so it will not factor any longer. So we have factored it completely. Now looking up here at this problem, it has 4 terms. But if I try factoring by grouping, it won't work. See, look. Pulling out a greatest common factor, x plus 10 is left. Pulling out the greatest thing in common, which is only a 1, left is 25 minus y squared. Look inside. Our parentheses are not the same, and therefore this does not factor by grouping. So we've got to use a different method. Alright, so if this ever happens, guys, if you have 4 terms and it will not factor by grouping, we're going to do what's called an alternate grouping. We're going to instead group the first 3 terms and then write them in their factored form, and then we will continue factoring if possible. So we're going to do an alternate grouping. Instead of grouping the first two and the last two, we're actually going to group the first three terms. Now if you look, the reason we would do that is because right here is going to be able to be factored. Uh-oh. I wrote down the wrong problem. This is actually a 10. Okay, so these three will be able to be factored. This is the same problem that I just showed you right here. It didn't factor by grouping, and now I'm just doing a different type of grouping. So this is going to factor. So this is two perfect squares. It has a middle term, so x and 5, and then we know it needs to add it to be 10x, and then x and 5 is 5x, and there's two of them, so that's 10x, so we're good with our middle term. We can use our trick, so this will factor to be x plus 5 and x plus 5. Plus because it's a plus sign right there. Then we have minus y squared. Now you want to rewrite that as x plus 5 squared minus y squared. Now this is your answer, but you have to notice that we're actually still able to factor this, because technically we still have a way to factor this since we have two perfect squares. So I'm going to do a U-substitution to make my factoring easier. So I'm going to just say x plus 5 is u, just so that it's easier to factor. U squared minus y squared. Alright, so now we say we have two perfect squares. There's no middle term, so this will factor to be conjugates. U plus y, u minus y. Now, instead of u, we got to put u back in, so that was x plus 5 plus y, and then we have an x plus 5 minus y. Okay, so it doesn't factor by grouping, even though we could check. So then instead we would group the first three terms, pull out the not pull out the greatest common factor. We could, but there's not a greatest common factor. So looking at this, we would factor it. What multiplies to be 16 and adds up to be negative 8. 4 times 4, negative, negative. We can quick factor, so this factors to be p minus 4 times p minus 4. So I'm going to write p minus 4 squared minus q squared. Now we have, once again, we've just noticed, we still can factor this because we have two perfect squares. I'm going to do a U-substitution to make my factoring easier. So then we have u squared minus q squared. We have two perfect squares with a middle term canceled out with a minus sign, which will give us conjugates. Then insert back in what we're dealing with here. So we have a p minus 4 minus q, and then we have a p minus 4 plus q. And we're done. Alright, looking at this one, once again, do not let your brain go away from these steps every time. Factor out a greatest common factor. I pull out a 3. So left is b to the 4th minus 16. Now you would have to notice I have two perfect squares, because when I square root it, they come out perfectly. So if I square root that, I get b squared. If I square root that, I get 4. So it has no middle term, so it's going to be conjugate pairs. Then we have our 3 in front. Now you better check. That doesn't factor anymore. Obviously that does not factor because it has a plus sign. But this does factor. So that's going to factor to be b plus 2, b minus 2. Another two perfect squares problem. So then we'll drop this down, b squared plus 4. And then we have our 3. So this would be our final answer. Make sure you factor completely. Okay, this is all of those things that we've learned so far, all the factoring. So if you have two perfect squares and it has a subtraction sign and you're missing a middle term, it'll factor to be conjugates. If it has two perfect squares and it has no middle term but it has a plus sign, you cannot factor it. If you have two perfect squares on the end, and if you multiply those together, 4x, and there's two of those, they add to be 8x, we can then factor it using our trick. So it will be that with the same sign as that twice. And then same here, so we have two perfect squares, and 4x and 4x would add up to be 8x, and needs to be negative 8x, so it would be minus signs. Okay, factoring two perfect cubes. So we factor this will become this. This will factor to become this. And I gave you a trick. I give you a trick to help you remember that. So this is the cute little trick I teach. So these are two perfect cubes. If I take the cube root of a cubed, I get a. If I take the cube root of b cubed, I get b. So I'm going to put in parentheses and then start my song. You take the front times the front, then the front times the back, then the back times the back. It's a little song we use. So the front times the front. A times a is a squared. Then the front times the back. that's AB. Then the back times the back, that's B squared. And then this sign will always be the same as the original. This sign will always be the same as the original. The next sign over will always be opposite of that. And then this sign will always be positive. Always. The ending term will always be positive. So that same thing works right here. Cube root the front thing, I get A. Cube root the back thing, I get B. Front times the front would be A times A, which is A squared. Then the front times the back is AB. Then the back times the back is B squared. Then you would say this sign and this sign are the same. The next sign is always opposite of that, and the final sign is always positive. And then we are done factoring that. Okay, so let's factor x cubed minus 8. So you'd say this is 2 perfect cubes. If I cube root that, I get x. If I cube root that, I get 2. So I have x and 2. Then you do the front times the front. Then the front times the back. Then the back times the back. And then this sign and this sign are the same. The next sign is opposite of that. The last sign is always plus. So now we have it factored, and then we could check, does this quadratic factor? So it multiplies to be 4 and adds up to be 2. 1 times 4, 2 times 2. Nothing. It does not factor anymore. Now here's a fun fact for you. If we ever have 2 perfect cubes, the quadratic in 2 perfect cubes will never ever factor. If you forgot that though, you could try factoring all of them and they won't end up working. So let's do that here. Cube root the front thing, I get x. Cube root 64, I get 4. So I put in my parentheses, then you do the front times the front times the back, then the back times the back. Then this sign and this sign are the same, the next sign's always opposite, and the final sign's always plus. This will not factor anymore. Okay, same thing here. Cube root the front thing, we get x. Cube root the back thing, I get 3. Front times the front times the back times the back. This sign and this sign are the same, and the next sign's plus, the final sign's always plus. Same thing here. Cube root the front thing, we get 2x. Cube root the back thing, we get 1. Front times the front, 2x times 2x is 4x squared. Front times the back is 2x. Back times the back is 1. This sign and this sign are always the same. The next sign's opposite, the last sign's always plus. And it will not factor anymore. Okay, looking at this one, it's 2 perfect cubes, because if I cube root that, I get 2x. If I cube root that, I get a 5m squared. And then I would do front times the front, which would be 4x squared. Then the front times the back, which would be 10xn squared. Then the back times the back would be 20. I can't write it right there. 25. I can't fit it right there. 25n to the 4th. So then this sign and this sign are the same. The next sign is always opposite, and the final sign is always plus. Hey, 2 perfect cubes. I think we're getting the picture with these. I'm going to do a different one. Hey, looking at this, you would notice this is 2 perfect cubes. It is 2 perfect cubes. Now that x minus 4 is kind of ugly, so I'm going to say let u is equal to x minus 4 just to make my factoring easier. So we have u cubed plus 8x cubed. And now you have 2 perfect cubes, so you cube root that, cube root that. We get a u, we get 2x, front times the front times the back, 2xu, back times the back would be 4x squared. This sign and this sign are the same, the next sign's the opposite, the final sign's always plus, but then we have to put back in our U-substitution in this one. So we have x minus 4 for that, plus 2x. And then we have parentheses right here, x minus 4 squared minus 2x times x minus 4 times plus 4x squared. Now we've just got to check, does this simplify? So combine like terms inside. 2x and 1x is 3x's minus 4. We've just simplified that. Now we got to multiply this out. So x minus 4 times x minus 4 would be x squared minus 4x plus 16. Then I would distribute this here and here, giving me minus 2x squareds plus 8x. Then we still have plus 4x squareds, so combine like terms inside. So we have 3x minus 4 still from here. Combine like terms, x squared minus 2x squared plus 4x squared is 3x squareds. Minus 4x plus 8x is 0x's, so that's gone. And then we have plus 16. Now this quadratic doesn't factor anymore. and we're all good here. We could check though if that factor is more, and it doesn't. Okay, so this is two perfect cubes. Two perfect cubes. So we're going to say let u equal x minus 2, let v equal x plus 1. So we have u cubed minus v cubed. So when we factor this, we will cube root the front thing, u, cube root the back thing, v. Front times the front, u times u is u squared. Front times the back is uv, back times the back is v squared. This sign and this sign are the same, the next sign is opposite, the last sign is always plus, but now you got to insert those back in. So we actually have inside our parentheses, our u is x minus 2, and we have minus, now parentheses, v is x plus 1. And then we have parentheses. Why did I put this in parentheses? Because it's minus all of v. So I need parentheses. We know how to subtract polynomials. That's just a rule. Then we have a u squared, which would be x minus 2 squared plus uv would be x minus 2 times x plus 1. Then we have plus v squared, and that would be plus x plus 1 squared. We can do advanced things, guys, so don't let a big nasty algebra problem scare you. Just be careful and go through it. You've got this. So we have x minus 2 minus x minus 1. I distributed that through. Then right here I have x minus 2 times x minus 2. So that's x squared minus 2x plus 4. Then I have plus, now I got to distribute this stuff together, x squared plus x minus 2x, and then we have minus 2. Now we have to distribute this out, x plus 1 times x plus 1, x squared, and it's plus, so plus x squared, plus x plus one. Now that's all inside our parentheses there. So combine like terms. X minus x is gone. Negative 2 minus 1 is negative 3. Then we have an x squared plus x squared plus x squared. It looks like that is 3x squared. Minus 2x minus 2x. That's minus 4x. Minus 6x plus 1x is minus 5x. Minus 4 minus 3x. 4 minus 2 is 2 plus 1 is 3. Uh-oh. What do we have in common here? Something more, actually. So we look at our answer and we say, uh-oh. We actually are going to pull out another thing in common. We're going to pull out a 3. So then we divide by 3, divide by 3, divide by 3. So then we have x squared minus x plus 1. We have a 3 we just pulled out, and we have a negative 3 in front. So that's now negative 6. X squared minus x plus 1. We could check, does this quadratic factor? It multiplies to be 1 and adds up to be negative 1. Nothing. So we're done. Alright, so do 5.6, guys. Make sure you pick and do every single type of problem. Go through and look for the ones that maybe look hard, and you're like, I've never seen one like that, because you want to be prepared for the test. I know this is hard stuff, but I know you guys can do it. If you study, you guys can do it, I promise. So, good luck.